To understand why the future is coming much faster than you might think, let's have a look at this graphic with a repeating S-curve in it. This curve represents the medium-term cycles of technological development. The horizontal axis on the bottom shows the year in human history, while the vertical axis on the left side shows the level of technology achieved at a certain time. We can see that the curve has some steep parts where the level of technology rises quite a lot within a short period of time, and some flat parts where the level of technology only rises slightly over long periods of time. The steep parts are called development phases. These are times where new sciences and technologies are discovered by humanity, which provide access to new engineering possibilities and technical applications. For example, during the first development phase in this graphic, most modern natural sciences were founded and completely altered humans' view of nature. Modern chemistry was derived from former alchemy, and the great scientist Isaac Newton discovered the laws of motion and basically founded modern physics. This era is called the scientific revolution. The flat parts are called maturity phases. This is where the newly discovered sciences and technologies are put into technical applications and mature over time through ongoing engineering and research. The first maturity phase in the graphic is the Industrial Revolution, which lasted until the end of the 19th century. During this time, a dramatic transition to new manufacturing processes began in England and from there spread rapidly to parts of Western Europe, the United States, and later on reached many other countries around the globe. Technology, economy, politics, and in fact our whole society changed completely during the Industrial Revolution. Water and steam engines hugely improved the production process of almost every industry. Telegraphy allowed the first time in history instant communication over large distances. Huge factories were built to enable mass production of goods, and land and water transportation got revolutionized with the development of steam trains and steamships. The Industrial Revolution is usually considered as the onset of modern technology and industry. The second maturity phase in our graphic is called the Digital Revolution. The Digital Revolution mainly follows the theories of the popular physicist Albert Einstein, the discovery of quantum physics, and the newly enabled manipulation of electricity. During this period, new transportation technologies like the car and the airplane completely changed our everyday life. The exploration of space started and satellites were brought into the Earth's orbit. Computer technologies were invented and are nowadays found in almost every household on the planet and countless technical devices. And of course, the World Wide Web and the Internet connect all people on Earth and reshape our civilization once again. So let's have a look where we are now. The graphic would suggest that we are somewhere here at the end of the digital era, just heading into the next development phase, which would mean that new sciences and technologies are just ahead to be discovered. But at this point I have to confess something. I cheated a little bit on this graphic to explain you the history of technology, because it's crucial to understand the basic concept of our technological development and why the future is coming so fast. Because in real, the boundaries between those eras of course are not so clearly defined as it shows here. It actually looks more like this, and the transition from one era to the next happens gradually. If we put a mean over the medium-term development curve, we get the trend of long-term technological development, which seems to be linear. But this is not the case, because in real, the maturity phase of each new cycle of development gets shorter than the one before. Which means that the digital era, for example, is shorter than the Industrial Revolution. And also the actual rise in technology level is in each new cycle larger than in the previous one. This leads us to an overall exponential trend in long-term development rather than a linear. To understand the difference between a linear and exponential development, let's have a look at the gingerbread man and the Terminator. If they would make 30 linear steps forward, they would end up, not surprising, 30 steps ahead. But if they instead would make 30 exponential steps forward, they would have walked around the whole globe 26 times. So the difference is that each linear step has the same increment, which makes the pace of change constant, while each exponential step doubles the size of the step before. So after our 30 steps here, this is the final ratio of linear to exponential steps. Another detail I didn't tell yet is that of course each of these phases can be broken down into smaller periods as well, the short-term development cycles. Let's take the Industrial Revolution again. If you'd want to subdivide a period, you could for example just outline every single major technology that was invented that time. So in this case, the invention of steam-powered machines, new methods in metallurgy, or any other technology that was invented during this particular period. The graphic shows the mean value of the short-term cycles to represent the medium-term trend, because the short-term ups are not so relevant themselves to explain the idea of this video. They are more interesting for economical issues. So to understand now the major reasons why our overall technological development follows this long-term exponential trend, let's have a look even further back in human history. It was about in the year 10,000 BC when early humans made the step from gathering and hunting to the first agricultural production of food, which is the starting point of our civilization. Then, over the upcoming millennia, only little new groundbreaking technology was developed. Like for example 5,500 years later, the wheel. In the year 1000 BC, humans finally developed the first sort of alphabet to preserve knowledge in an easy comprehensible way. But it took until the year 1400 until the first printing press was invented and books could be produced without the tremendous effort of handwriting every single copy. Of course, there were other important technologies along the way too, but I just picked out a few particularly relevant ones to explain what's going on. So we see that from the invention of the alphabet to the invention of a printing press, we have a time gap of 2,400 years. While in comparison, when the first car was invented in 1886, it took only roughly 100 years until humanity has launched the International Space Station ISS. But on the other hand again, it took almost 5,500 years from the invention of the wheel to the first motorized car. So it took 55 times longer from the invention of the wheel until the first motorized car was built than it took from the first motorized car to launch the ISS. So we very clearly can see that the overall development of new technology got incredibly accelerated in recent history. There are really many reasons why this is the case, but we're just gonna discuss two particularly relevant ones here, which seem to be quite obvious once you hear them. The first one is that technology that we have invented once naturally is utilized to develop new technologies. And as this pool of available technology grows larger and larger with every new invention, the amount of possible combinations and concepts that can be realized grows as well. We needed to know the technology of the wheel to build the first car, but we also needed to know engineering, steelmaking and some sort of engine technology to combine and bring them together intelligently for the development of motorized cars. And of course, modern cars nowadays are packed already with so much more technology than 100 years ago that it actually needs much more than that. So at a time when the necessary technology to build an engine was not developed yet, a car was basically a carriage, and the engine were the horses who pulled it.
Fine chariot, but where are the horses?
And this leads us to the second main reason for the exponential growth rate, which is that already existing technologies are getting redeveloped or further developed. Just like individual transport developed from the carriage in former times onto bicycles, cars and boosted boards nowadays. With newer technological knowledge and methods, it's of course possible to improve already existing ideas and update them to the state of art. Okay, but wait. All of this would mean that we've already passed the digital revolution and moved on to the next era, right? And exactly this is the case. We are already in the next technology phase in human history, the age of information. An era where everything is about information-based computer technology. This is the onset of a new era in human history, and it's just as fascinating as it possibly could be. So just like after the Industrial Revolution, when the political, economic and social systems were completely restructured, the planet is being transformed right now once again. We can see that the largest companies nowadays are in fact those that are either in the development of the new major industry of this era, which is the information technology industry, or those that use the new technology to reinvent existing concepts, like trade or communication. And many others are on the rise, equipped with the new power of information-based technology to develop existing concepts and bring new ones to life, like robotics, computer-supported research, design and production, artificial intelligence, self-driving cars, and so on. So we are actually living in the time just where the exponential curve is getting steep and clearly separates from the linear. And in fact, most of the technology we use and depend on nowadays just got developed in the last century. Radio, fridge, camera, airplanes, agricultural machines, phones, and the World Wide Web are just some of them. So the last question to ask now is, how do we actually know that right now we are in a new development phase, where the technological progress is made so rapidly? And the answer is, because we know exactly what the new sciences and technologies are, and we even got it proved that they evolve exponentially. The new science is computer science, and it is computer-based information processing that's completely altering the way we live and work. To understand the pace of growth for the current time in particular, let's have a look at our medium-term development curve again. Again, I need to tell you that in real there are many reasons that cause this evolution, but talking about all of them would exceed the content of this video, so again, we are going to pick out one of the major reasons that sums it up pretty well. It was in 1929 when a man named Gordon Moore was born in the United States. He became one of the pioneers that knew very early about the upcoming rise of computer technology, and fascinated by it, he co-founded the company Intel. He's also the author of the concept that explains one of the main reasons that caused the exponential rate of growth in computer-based technology, Moore's Law. In 1965, he predicted that the number of transistors on integrated circuits would double every year, which, as we have learned already, means exponential growth. He later revised his predictions to a doubling roughly every 2 years. And this latter prediction is proved accurate until now, and most experts believe it holds true at least 5 more years. By then, the exponential progress will continue through 3-dimensional computing. If you ask me, I would say we live in one of the most exciting times we possibly could. A gigantic transition in our civilization and on our whole planet that will alter the life on Earth completely is happening just right now. Of course, and luckily we can't say yet what the future will bring, since nobody likes spoiled surprises, but we can have a superficial idea of the technologies we can expect. Nanotechnology, artificial intelligence, space exploration, bioengineering, superconductivity and neuroscience are just a few of the headlines that will stand above countless inventions of the future.
We might see a few nanorobots coming in at the end of the 2020s, but I think the 2030s will be when they are deployed medically in a large way and start to displace most other forms of medical technology.
People have an unlimited amount of desire and willpower to extend their life. This desire and willpower will be channeled into economic forces to propel biotechnology until we achieve, well before the end of this century, the death of death.
We're doing these things that seem unlikely to succeed, and we've been fortunate, and at least thus far they have succeeded.
What we'd like to do is to establish a city on Mars and help make humanity a multi-planet species and a true spacefaring civilization. That's the ultimate goal.